Welcome back to Math Video Tutorials, and thank you for tuning into this exercise. In this exercise, we'll be sketching the graph of this function 3 over 1 plus x squared, where the values of x or the domain are the set of real numbers. And in the second part, we'll look at the range. Okay, so let's start by sketching. Whenever you come across sketching, the first thing or the first stop you should look at is the y-intercept, because that's an easy one. You just make x equals 0 into your function. We just make x equals 0 and substitute it into here. That becomes 0 squared is 0, plus 1 is 1. 3 divided by 1 is going to be 3. So the y-intercept is 0, 3. The second point to study when you're sketching graph is the x-intercept, or as they call the roots. It's where the graph crosses the x-axis, basically. In order to find the roots, you need to make y equals 0, or in this case, f of x equals 0. So we need to solve 3 over 1 plus x squared equal to 0. And you try to solve it. Now for this one here, it has an expression in the denominator, and that denominator, or that algebraic expression, cannot be equal to 0 because you cannot divide by 0, so leave it alone. So this denominator, you can see for our fraction or function, is already different from 0, so this function can never be equal to 0. So we just say not possible. And what that means to our graph is that it does not cross the x-axis. So basically, no roots. The next stop will be the any turning point, or as they're called, stationary point. First thing to do when you are calculating or locating the stationary points, you need to differentiate your function. So we need to work out f dash of x. That's the derivative of this one. This is algebraic fraction. If you have in general a function y, which is u over v, as a algebraic fraction where u is a function of x, or in terms of x, v is a function in terms of x. Now to do y dash, with the derivative y, we need to do u dash times v minus u v dash divided by v squared. So that's the formula for differentiating algebraic fraction. And we're going to use that for this one here. So the derivative of 3 is going to be 0. Let's first draw our fraction. Now we know the denominator is 1 plus x squared, so we can go ahead and do it now. 1 plus x squared all squared. That's what you need to do. Just take the denominator and square it. And so the derivative of numerator is 0 in our case, and times it by the denominator. It's going to be 0. Well, the denominator is going to be 1 plus x squared, but the answer is going to be 0 minus the numerator, which is 3, and we times it by the derivative of the denominator. So differentiate the denominator, that will give us 2x. So f dash is, this one is 0, negative 6x over the denominator 1 plus x squared all squared. And if you have a turning point, let's say this curve like so, so you got this turning point here, which is a maximum, and that turning point exactly here, the tangent at that point, if I could do it properly, the tangent at this point here, the gradient of that tangent, dy with respect of dx, is equal to 0. So for us to locate the turning point, we need to make it equal to 0, similar to this. Alright, so basically we have minus 6x over 1 plus x squared all squared equals 0, then negative 6x has to be equal to 0 because the denominator cannot be equal to 0. So therefore, x is equal to 0, which means that the turning point happens when x equals 0. And for that, the y coordinates, or the f of 0, is going to be, of course, 3. Similar to what we did in the y-intercept there. So we can say 0, 3 is the turning point. Let's write it down like this. Now we have determined the turning point, but we have not determined the nature of this turning point. Is it a maximum like this one here, or is it a minimum like this one here? So in order to do that, we need to do the second derivative. Basically, we need to take this expression and we differentiate it one more time. So we're going to do it quickly. Minus 6x, we need to differentiate it following the formula here. So that is minus 6 times the denominator, which is 1 plus x squared all squared, minus the numerator. That's what it is, numerator there. So the numerator is minus 6x. And we times it by the derivative of the denominator. This one here, we need to bring down the 2 first, as you would do when you differentiate any expression. So you need to bring down the 2, and then multiply by the derivative of the expression inside the bracket. So the derivative of 1 plus x squared is going to be 2x, and multiply by the function itself with the expression, but with decreasing the power. It's going to be 1 plus x squared to the power of 1, okay? And we're going to divide by, of course, the denominator all squared. So that will give us a squared of a squared is going to be 4, because 2 times 2 is 4. Before you go any further with this, just remember the turning point happens when x equals 0, and we're doing this to find out the sign of the second derivative, because that will tell us the nature of the turning point. Let's recap on this one here. If you have the second derivative is greater than 0, meaning positive, then the turning point is a minimum. So we're dealing with the minimum. If the second derivative is negative, then we're dealing with the maximum. And that's what we're trying to do here. So the turning point happened at 0, x equals 0, so we need to substitute it here. So we need to do f dash dash of 0. Clearly you can see 6 times 0 is going to be 0, and that would eliminate all this bracket here or expression. So all this will go away. And then here you got 0 plus 1. It's going to be 1. 1 squared is 1. It's going to be minus 6 divided by 1, because 0 squared is 0 plus 1. 1 to the power 4 is 1. So the second derivative is negative. So we are dealing with a maximum turning point. Just to recap, 0.3 is a maximum. So let's write it down here. So 0.3 maximum. The next, what we need to do is to look at the graph when the values of x gets very large on the positive side of the x-axis and very large, or very small, sorry, on the negative side of the x-axis. We say x tends to positive or plus infinity. What happened? I mean, this value here will get elevated above too if the value gets very large. So it will get even larger. So basically we are dividing by even larger number. And whenever you divide by a large number, you get very close to 0. What we're going to say, if x tends to positive infinity, the function f of x will tends to 0, will approach 0. Right, we write it down like this, and we say tends to 0, meaning approach to 0. It will never cross 0, so it will just get close to 0. And same thing for the negative values or negative infinity. The function also will get to 0, because if you have a negative number, you elevate it, whether small or large, it will turn to positive, and the same thing as before here. All right, so let's sketch the graph. So when you're sketching a graph, first thing you need to do, mark all your important points. In this case, we haven't got that many. We got this, the y-intercept, which is 0, 3, and at the same time is the maximum we just worked out, this one here. What is it? This one here, yeah. So basically, let's mark it 0, 3 here, right? And mark it 3. And we just studied the graph at very large and small values. It will tend to 0, meaning the x-axis will act as an asymptote. So our graph will approach but never cross the x-axis, crosses the y-axis at 3, go down, approach the x-axis again, but never cross it. So that's the shape of our graph, and I should have marked here 0. Okay, so what about the range? So we're gonna write down here the range. Well, you can see the function is located, or the values of y, that is the function, between 0, not included, because remember the graph does not cross the x-axis, and the value of 3. So we're going to say f of x, that is our function, is greater than 0 and less or equal to 3. So that's the range of our function. Alright, I hope this video tutorial was helpful. Thank you for watching.